Okay, so we heard the previous class what STP is. We learned that IEEE 802.1d spanning tree protocol prevents loop, and you no need to enable it, and it's enabled by default. We saw the election process, root switch election, how a root port is elected, how the blocking port is selected, and so on. Before we get into the other flavors of STP, there are other flavors of STP actually, because the default one is slow. IEEE 802.1d spanning tree, which is there running by default, is slow. In Cisco, that is the default. In the other vendors, I have seen uh, the other standards, better standards are by default. We will see those things later. So before we get into those advanced stuff, let's learn VLANs. Virtual Local Area Network, VLANs. You know what is local area network? Can anyone say what is LAN, local area network?
So, a communication channel within an organization or company.
Okay. Any other answer, you know? See, within an organization, we will have,
Within a closed entity.
come again, within,
Within a closed entity, sir.
okay. Right.
So, users can communicate within the closed entity.
Mhm. Okay. Example, can we say a department, a LAN? One department is one LAN. They are closed entity now. All the sales group, they are
Yes, sir.
one LAN. We can say like that, right? Correct. So
Yes,
an
sir.
organization is not a LAN. Within an organization, you may have many subnets. Each subnet is a LAN. Each subnet is a LAN. Member of the same subnet, do they need a routing? No. Member of same subnet, they no need router. There is no need for routing because they are all member of same subnet. They need only switching. So a switch is a LAN. Member of same device. Sorry, same subnet. The devices of same subnet, they no need a router. All they need is a layer 2 device to communicate, which is a switch. So by default, all the devices connected to a switch will form a group and they will all communicate. There is no restriction because by default, in one switch, there is only one LAN. If I take this switch and connect to another switch, which has got another 100 computers, how many LANs I have, you know? Still, it is only one LAN. It's not 1 plus 1, 2. It is still one LAN. You know why? When I connect this wire to this switch, this and this get merged. We call this as broadcast domain. Broadcast domain. When a broadcast packet is sent, it will not only goes to this, and this, it will also go to this because they are all merged as one single group. So if you have another switch, another 3,000 computers, all form one big group, one LAN only. So connecting switches serially like this They are not going to create multiple LANs. They are going to form one large LAN. When it was only 24 port switch, your LAN was only 24 device size. When you take another 24 port switch and connect another 24 computers, and it becomes a larger LAN. More switches you add, more larger the LAN size becomes. In another word, more switches you add, the broadcast domain gets bigger and bigger, bigger and bigger. Here you got 24 computers, here 24 PCs, another 24 PCs. They all form one big large broadcast domain. இங்க ஒரு broadcast packet போய் இந்த போர்ட் இடிச்சதுன்னா மொத்த பேருக்கும் அது போகும். ஆமா, அதனாலதான் that's why we call it a single broadcast domain. There is no controller to stop the broadcast anywhere here. They all form one big cluster, big group. This is LAN. For these computers to communicate, they all need to be in same subnet. 10.1, 10.2, 10.3, 10.4. Let me say 10.5 here. 10.0.0.50 here. 10.0.0.100 here. They all can ping each other because they're all in single local area network, LAN. Now, what are we going to learn is not LAN. We are going to learn VLAN, virtual LANs. Virtual LAN, VLAN, is not a physical LAN. We are going to virtualize LAN. I told you LAN is a switch. And when I say VLAN, I'm creating virtual switches. Yes, VLANs are nothing but virtual switches inside one physical switch. You see, you got a large size switch and there are many ports. Let's say you got 300 port switch. Funny, I cannot move this. So I have to draw. Assume you have 300 port in the switch. Now you may not have 300 employees in one department. You will not be having 300 employees in one single department. So let's say you got 30 in one department. Assume this one port is 10 port. This red computers, 30 computers, I said one port is 30 port, assume. So you got 30 employees working as help desk. It's a very big office, maybe a big shopping mall. So there are many help desks. Or big airport like Dubai airport. And you got admin group. Another 60 airport administration. Dubai airport. 60 administration group, and you got 30 purple, housekeeping, right? Likewise, you got another 30 of another department. Sorry, another 30 of another department. So you got 5 departments here. You got 5 departments. You might have even done subnetting. Let's say you did subnetting here. You said 10.1.0.0/16 for help desk, 10.2.0.0/16 for admin, 10.3.0.0 for housekeeping, 10.4.0.0.0 for the patrol, security patrol, and another 10.5.0.0/16. This is for immigration checkpoint. So in this airport, you have done subnetting, but the problem is the network, the underlay, the layer 2 is single LAN. Very, very pathetic situation. After you do subnetting, layer 3 is separate. No problem. I understand, this is a different network, this is different network. They cannot talk without the help of a router. They cannot talk without router. But the problem is the L2, the layer 2 is not separated. You simply have one LAN with 6 departments. No use. What will happen, If the housekeeping guy wants to see what is going on with the admin group, he need to simply change his computer's IP address 10.2.0.10. If he changes his IP address, he will come and talk to this computer. 10.2, 10.2. No security here, you see, because they're all connected to one single local area network. Anytime a member of a department can interfere with other member of another department. No security. What is the solution? You create some isolation between these departments. Isolate them. Isolate them. How do you isolate? Slice the physical LAN into multiple virtual LAN. That is what called as VLAN. Slice it. Now, physically it is one switch. Virtually it is 5 switches. So you don't need to buy 5 physical switches to separate these guys. You can just create VLANs, 5 VLANs, and put these 5 members in put these members in their respective VLANs. Create 5 VLAN for 5 department, and in the first VLAN put all the help desk member. The second VLAN put the admin department, and so on. Now, if this housekeeping guy changes his IP address 10.2.0.10. Can he go here? No, not allowed. He cannot cross this border. The virtual LAN isolates. Housekeeping group, even if he changes his IP address, he cannot talk to any of this 10.2 because there is an isolation. They will not be able to communicate because they all belong to different VLANs, different broadcast domain. In a switch, by default, there will be only one broadcast domain, which we saw in the previous picture somewhere. By default, all will be able to communicate each other. But after creating VLAN, you have created multiple broadcast domains. In another word, you have created multiple LANs. In another word, you have created multiple switches inside the physical switch. You have created multiple virtual switches. Member of a virtual switch cannot talk to another virtual switch member. Why? Because they belong to different VLAN, different group broadcast domain. See? So VLANs helps us to create virtual switches inside a physical switch. A member of a VLAN cannot talk to other VLAN member because there is total isolation between these two VLAN groups. This is more safe, you see. Just subnetting and putting the members of the departments in different subnet is not sufficient to guarantee safety, security. You also need to separate them in a layer 2 level. Creating subnets and giving subnets to department is only layer 3 separation. Layer 3 is a logical one. Physically, they're all connected to one physical switch. There you need to have a security. There you need to have a separation. For that, we need to create VLANs. Creating VLAN is creating multiple broadcast domain. By default, how many broadcast domain will be there in a switch? Only one by default. By default, all 300 ports will be a member of single VLAN. We call it as VLAN number 1. VLAN 1 is the default VLAN to which all the ports of the switch mapped to. But now what I have done is I have created like VLAN 10, VLAN 20, VLAN 30. 5 VLANs I created. And I put some interface as a member of VLAN 10, some interfaces as member of VLAN 20, some as member of VLAN 30, some as member of VLAN 40, some as member of VLAN 50. So that the 50 members can talk each other, 40 members can talk each other, 30, 20, 10, they all can talk to their respective group members, but they cannot talk to other VLAN members. So I have achieved the security by creating VLANs. I have isolated them. Let me quickly show you, and then I'll take you to the next slide. Right. You see, let me show you again because I think I passed the recording. So I'm showing you again. Initially, when we checked, all the interface were member of one single VLAN. That's why we say a switch is a LAN, one VLAN. but we want more switches. So what we do is we create some switches called VLAN 10. Optionally, you can name it VLAN 20. And then we take the interface and interface 1 to 12. That's our plan. We want to take these 12 ports from VLAN 1 and give it to housekeeping. And we want to take 13 to 24, give it to admin. That's our plan. So for that, what I did is I use this command interface range fast Ethernet 0/1 till 12. I go to those interfaces and say you belong to VLAN 10. Likewise, I went to 13 to 24 and I say you belong to VLAN 20. After saying that, when we verify by typing show VLAN brief, we can see those VLANs and the members of those VLANs. Please ask me a question.
So will the default also will be counted as
Yes.
broadcast domain?
If you remove those interface, let's say I create VLAN 30 and I don't want to give a name, it will automatically give a name. And I'm going to say interface range G0/1. Access VLAN 30. Now if you go and see, this is one broadcast domain with this two interface, and this broadcast domain is empty, so you cannot consider it as broadcast domain because there is no member. Even though one VLAN is one broadcast domain, it's an empty switch, no ports. Who will broadcast when there is no port? You need a port to send some broadcast anyway, but still, you consider it as a broadcast domain. Now, if someone is asking how many broadcast domain you have, then you have to say 4, even though there is no member. But reality is only 3, because the default VLAN has got no member at all. There is no one to send a broadcast. So there is no need for a broadcast controller there. It's a switch without any port. Any other question?
Okay, sir.
Okay.
No, sir.
Now, what we have seen is how to create VLAN and how to allocate interface to the VLAN. You will start doing the labs from today onwards. For that, you need to download this tool. Please download this whenever you have time. Now let us go back. Let's say you got another floor in your office. You got another floor. First floor and second floor. In second floor also you have some help desk people, admin, housekeeping, and immigration desk, security. Same like Dubai airport. In Dubai also you have floor 1, floor 2, floor 0. You will have immigration desk for interconnection, immigrants. You will have a separate desk. You will be connecting from one flight to another. It will be in the first floor. You don't need to go to 0th floor or second floor. Sorry. It will be in the first floor. You don't need to go to the 0th floor. Anyway, assume that as an airport and you have 2 floors, and each floor you have these departments, same departments, scattered in first floor and ground floor. How do you connect? I want this help desk people and this help desk people to form a group. Even though physically they are not in same floor, even though they are not in the same floor physically, I want to group them in network as one group. How can we combine that and this? Very simple. You need any port on the switch and connect like this a wire and configure this port as a type called trunk. Trunk port. What is a trunk port? The port which is a member of all VLAN. What is a trunk port? A trunk port is a port that can carry multiple VLAN traffic. Multiple VLAN traffic. You see, this is not a trunk port because this is a member of a single VLAN. Then what do you call that port as? Access port. Access port is a port that is a member of a single VLAN. When you make a port as a trunk port, you can make any port as a trunk port. For example, you see in our switch here, I'm going to make port 12 as a trunk port. See what happens. Listen carefully. 12 is right now in housekeeping. But when I go here and say interface F0/12, switch port mode trunk. When I say you're a trunk, this don't belong to now a single VLAN, so it won't be listed anywhere. Did I say trunk? Interface, yeah, switch port mode trunk, yes. When I say trunk, it should not be a member of VLAN 1, VLAN 10. Oh, it is shown still, it is listed here. Show interface trunk. Okay, the reason is this. Because the links are down. The links are down. But as soon as I connect this wire to 12, see what happens. Now, the 12 port has just come up. If you go and search now, it is coming under a trunk. Show interface trunk. It shows this is the interface right now trunking. And now if you check VLAN brief, 12 is missing, gone. Why? It is no more a member of a single VLAN. That's why it is missing. It's a member of all VLAN I told you. You see here. Currently, these are the VLANs that we have in our switch. It says this port is now allowing these VLAN traffics. That's what trunk is. A trunk port is a port that can carry all VLAN traffic. Now, you know what? This help desk, I'd say there are 30 members here. Here there are 30 members. Now, this forms one 60 port switch. Physically, they are in different switches, but they combine, and these two forms one switch virtually. Likewise, this forms another switch. What I'm trying to say here is, if this sends a broadcast, if there is a broadcast packet hitting this port, it will go to this one, and it will also go to these three. Through the trunk, it will go. Likewise, if there is a broadcast in the housekeeping, if there is a broadcast in housekeeping, it will go to this one, as well as this three. So physically, though they are in different switch, they form a virtual switch across the physical boundaries. It is possible because of this trunk port. Any port you can configure as a trunk port. You saw me doing it. I just took randomly one port F012 and made it as a trunk port. Now, how do we define a VLAN? Our topic for the day is VLAN. So far about VLAN, I have given you a lot of angles, a lot of different perspectives of VLAN I have spoken to you. VLAN is a switch, I said. VLAN is a virtual switch inside a physical switch. VLAN creates multiple broadcast domains. By default, in a switch, there will be only one broadcast domain. By creating multiple VLANs, we create multiple broadcast domain. So we get security. Member of a broadcast domain cannot talk to another member of another VLAN. Other member of other VLAN. And VLAN, regardless of the physical switch, they can form group. Via trunk port, they can form group. The virtual switches may have a member, the port membership from various switches. In our case, there are two switches here. For each VLAN, the ports are taken from two different switches and they form one switch. Now, someone tell me how many virtual switches I have in total in this diagram here. How many virtual switch I have? Do I have 10 virtual switch or 5 virtual switch or yes, 5. So that answer helps me to
5,
understand
sir.
that you understood the VLAN. Even if you have another switch, and when you connect a trunk port, still how many virtual switches you got? Only 5. All these red in 3 switches, they form one virtual switch. All the admin in this 3 physical switch forms one switch. You see, the broadcast domain gets extended to the other physical switch via this trunk port. What is a trunk port? The port that can carry multiple VLAN traffic. By default, all the ports are access port. What is access port? The port that are member of a single VLAN. And what is the default VLAN? VLAN number 1. Trunk port you need to configure. You can take any port, connect the wire back to back between the switch and go configure switch port mode trunk so that multiple VLAN traffic can pass through. Did you understand VLANs?
Yes, sir. Sir, may I know what is the broadcast domain
Only
for
5.
all these three, sir, together?
5 broadcast domain. Each VLAN is one broadcast domain. To make
Okay.
you understand, let me give you an example. If this PC send a
One broadcast
broadcast,
domain. Okay, sir. Okay.
it will go to this 2 and then these 3 and then this 3 because they're all in single broadcast domain. So 5 VLANs, 5 broadcast domain. Regardless of how many
Okay, sir.
switches, that doesn't matter. If you are connecting through a trunk port, you are simply extending this VLAN 10 to other 2 switches. It's the same broadcast domain that you have extended. Yeah.
Okay, sir.
Please ask.
There's one doubt. Yeah, is it possible for
Good
one
question.
switch port to be a part of
Answer is
two
no.
or more VLANs?
Question is, can I take this port and assign it as a member of VLAN 10 as well as member of VLAN 20. No, not possible. One port, one membership. You cannot take one port and make it as a member of two broadcast domain. That is not possible. Answer is no. Any other question? It was a very nice question. Okay. So it is only the trunk port that can take traffic
No,
from
sir.
all VLAN. Okay. We have learned about VLANs. Now it is right time to go back to our STP topic, spanning tree protocol. The spanning tree that you have learned so far is IEEE 1D. There is a drawback in this. What is that? You see, let's say there is a block here. So all the traffic from A to B will only go via the upper path. Now, if there is a break in here, if there is a break here, there's a cable cut. What will happen? This switch will recognize it because it is directly connected. But this switch won't. This switch is not connected to the broken wire. So for this switch to realize that there is a break somewhere, it will wait for 20 seconds, even this switch. The BPDU from this part is not coming here now because there's a cable break. Even here it is not coming to the switch because there's a cable break. So after 20 seconds of waiting, not hearing from this portion of the network, this port goes to listening state, which is another 15 seconds. After 15 seconds of listening, it goes to another 15 seconds of learning the new topology without this wire. That's another 15 seconds. After this, only the packet will start flowing like this. So approximately it takes 50 seconds for the convergence. Approximately it takes 50 seconds to unblock this blocking port, to unblock and make it as an active link, forwarding link. It takes 50 seconds. This is very slow, not acceptable in the real world. See, 300 millisecond is what the maximum acceptable delay for a voice traffic. Hello, nalla irukringala? When someone wants to talk to you over phone from America, that hello, nalla irukringala is audible for you, clear and sound. It is because the delay is not more than 300 millisecond. 350 millisecond also will create problem for the listeners. Like 13 years before, I was in Afghanistan trying to talk to my family. And when I say hello, immediately the response won't come. because they did not hear me. We are connected, but it didn't reach on time. So I'll be repeatedly saying hello, 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 hello. And here also they will be saying, yes, yes, I can hear you, I can hear you, I can hear you. It will come later, after some time. I can hear you, I can hear you, I can hear you. And my hello will reach them only. So delay is not acceptable. Delay is not at all acceptable. 50 seconds is too much. I'm talking about 300 millisecond is the acceptable delay. Millisecond, not even second, millisecond. See, this is taking 50 seconds for convergence, for unblocking. So we need a better fast converging STP. We want fast converging STP. That's what called as rapid spanning tree protocol. See, fast, rapid. This is according to IEEE 802.1W, 1W standard. And then we will learn another spanning tree called per VLAN. We just learned that we can have many VLANs. Per VLAN spanning tree plus. This is Cisco protocol, Cisco standard. After which we'll be learning another spanning tree called multiple VLAN spanning tree, MST. This is according to IEEE 802.1S standard, 1S. Multiple VLAN spanning tree protocol. More detail we will discuss in our next class. We'll stop here.